Okay, this video I want to give you a mini lesson about the first topic in chapter 10. So I wanted to open up your PowerPoint file and then just go through with me the same time. So the first thing I want to mention is, as I said, from the very beginning of the semester, I first introduce the things you're familiar with, like the Earth, the Sun, and the Moon, and then we move outward. So we talked about solar system last class. Now we are going to move a little bit further away to talking about the stars. And in fact, this chapter is one of my favorite chapters to talk about in astronomy. So the observable universe contains about several tens of sextillions stars. So sextillions is about 10 to the 21st stars. Okay, so there are so many stars in the sky. How can we know about them? Okay, so astronomers, they find a way to categorize these stars. Okay, so there's many features we can learn about stars, such as the brightness of the star, the color of a star, and the chemical composition of a star, the size of a star, and mass of a star, whether a star is moving or not. So how can we find out these properties? Okay, so that's the first thing we're going to talk about this chapter. The second chapter is, the second thing we're going to talk about in this chapter is based on all these stars, how we can categorize all these stars, and so we can understand much better about the life cycle of the stars. The first slide actually under chapter 10 talks about parallax, and if you still remember, I asked you guys to do an experiment in class. It's like, put your finger on your nose and then put your finger further away so you can experience the parallax concept. But how do we use parallax to find out distance? Okay, so you can see actually there is an equation we can use. The distance equals 1 over parallax. So the parallax has to be in the unit of arc seconds, and distance has to be in the unit of parseconds. Okay, and I will also post some notes actually online, so you guys can follow my notes as well. Here I want to give you an example. So let's say if you have parallax is 0.5, so you use 1 over 0.5, you can find out the distance is 2 parseconds. So that's how you do. That's how you find out the distance. Okay. Again, I'm going to post some notes online so you guys can see more examples through the notes. If you go to the next slide, actually you can see that the next nearest star to the sun is called Proxima Centauri, and we talk about this in class. It's about actually 4.2 light years from the Earth. And then you can see here on the slide, we use marbles, we use sand, and we use another marble to represent the sun, the earth, and star, which is actually the same method we use from the tutorial exercise I asked you guys to do. And this slide shows you the 30 closest stars to the sun. So you can see they are very, very far away. So that's why when we talk about stars, we're not using the unit of light year. Rather, we would prefer to use a unit of parseconds. The stars actually, they move. If you go to next slide, you can see the stars actually, they're moving. Okay, so they're not only moving sideways, they're also moving towards the sun as well, as you can see from the slide. The next topic about luminosity and apparent brightness actually is one of the most important topic in this chapter. So the first thing, the key word is luminosity. Luminosity, sometimes called absolute brightness, is how much light actually emitted by a star. Apparent brightness is how bright a star appears when viewed from Earth. So appears is a very important word here. Okay, it depends on the absolute brightness, but also on the distance, how far the star is away from us. Okay, if you think about this as an example, like if you're driving a car, okay, so you during the nighttime you turn on the headlight. The headlight, actually the actual light emitted by the headlight is going to be the same. It doesn't matter whether the car is closer to you or is further away from you. But when the car is much further away from you, it appears dimmer. When it's closer to you, it appears much brighter. So the actual amount of light the headlight emits is called luminosity, or we sometimes call absolute brightness. But how bright the headlight appears to you is called apparent brightness. So apparent brightness is something appears to you. And there's another equation here tells you about the relationship between apparent brightness and luminosity and distances. And you can see that if the luminosity is bigger, then the apparent brightness actually is bigger. So if let's say if the headlight has more watts, so it's going to have more light emitted, but then at the same time it's going to appear brighter if the same distance away from us. So when the distance is getting bigger, so the apparent brightness actually is getting smaller, because we know that the headlight example, if the car is much further away, it's going to appear dimmer to you. And as you can see that, okay, the distance squared is at the bottom of the equation. So this is called inverse square law. We mentioned this inverse square law at several different places. One place is actually, we talk about the gravitational force. The other place we talk about telescopes features. And then this is the third place we talk about inverse square law. So inverse square law means that you square first and you inverse it. So if you look at the apparent brightness relationship with the luminosity and distance squared, you can see that when the distance is doubled, actually the apparent brightness, actually you have to do 2 to the 2 first, becomes 4, and inverse it is 1/4. If 3 times bigger, then it's going to be 1/9. Okay, so if you go to the next slide, which shows you 2 stars, A and B. So it's possible that 2 stars that appear equally bright might be a closer, dimmer star and a further brighter one. Okay, so if 2 stars appear equally bright, it could be we have a closer star but it's dimmer, and then we could have a much further star but it's much brighter, so they appear the same brightness to us. So that's if you go to next slide. Okay, so this slide actually summarizes the apparent brightness. How do we represent the apparent brightness in astronomy? Okay, so the most important thing here, before we talk about that, I want to emphasize one more time again. So the apparent brightness is the total amount of light emitted by a star. Okay, the actual amount of light emitted by a star. But apparent brightness means that a star appears to us. Okay, so those are two different concepts. So in astronomy, we use actually a number we call the magnitude scale to represent the brightness of a star. Okay, so it's Uh, the last sentence on this slide, it says it is also inverted. Larger magnitudes are dimmer. So which means that if something is dimmer, actually the number is bigger. Okay, the larger magnitudes are dimmer. So if you look at the left-hand side here, the sun is very bright, but the sun has a very negative number, negative 26.7. Okay, so the smaller the number, the brighter the object is. So that's the way how astronomers decide to represent the apparent brightness of a star. Okay, so that's the most important thing actually I want to cover for today's lecture. And I'm going to also ask you guys to practice on a tutorial exercise. I'm going to post on the Blackboard, which is called apparent and absolute magnitudes of stars. So you don't have to do number 4, you don't have to do number 6. So I would like to ask you guys to try on that worksheet, and then next class I'm going to talk about that worksheet, and then we're going to talk about the next topic.